Aloha and welcome to Module 6, Lesson 12, Video 1. And today we are going to graph and classify quadrilaterals in a coordinate plane. And we're going to start out with a little mystery, and we're going to come back to this mystery at the end of the video lessons. So keep watching so you can find out what quadrilateral is hidden by these post-it notes. Sorry, my dog is scratching on the carpet. Why did they decide to do that right as we're starting the video? Hey, Teddy, stop. Thank you, Teddy. Okay, so squares A, B, C, and D cover a figure that is graphed in the coordinate plane. I will remove one square at a time to show part of the hidden figure. Each time I will say what the hidden figure might be and think about whether you agree or disagree based on the evidence, okay? And before we do that, let's just do a little review of some of the vocabulary that we've been working on. We're going to be using some of this vocabulary to think about the hidden coordinate figure, okay? So a point, like point A, is called A. Then we have a line segment, and you see that it has points at either end. That's what makes it a line segment, because it doesn't go on forever. It is stopped at both ends. And we show it by AB or BA. It could be named by either one of them first on your line segment. Then we have a line, and you see that it has arrows at both ends, meaning it goes on forever, and it can be named by CD or DC because they're both points on the line. Then we have ray EF, and you might notice that it has a point on one end and an arrow on the other. So it can only be named EF because we always use the one that has the point first. And then the arrow second. Any other point on it besides the point where it stops. Okay, so this is where you could say it starts or it stops, and then it goes on from there, and that is called a ray. Then we have an angle, and an angle like this one. Notice that when we name it by the point that is making the angle, right? So we have two lines going together. You can see that they go on forever and they meet at a point, and our point is G, so it could be called angle HGI, angle IGH, or just angle G, but we're definitely focusing on the G. Okay, that was our quick vocabulary review. Now let's jump in to our little mystery on the coordinate plane. All right, so if I take off the A, okay, what do we have left if I take off the A? Just looking at this dot and this line, do you think it could be a line? Think about what we just said about lines. Yes, lines go on forever in both directions. So for this to be a line, it would have to have an arrow there and not a point. Could it be an angle? It could have, this could be the angle, and it could have one line going this way and one line going this way, and they could meet at that point. Could it be a polygon? That could be an angle on the corner of a polygon. Remember, a polygon is a closed shape. Could be quadrilateral, could be any number of sides. We don't know because it's covered, right? Okay, how about if I take off B? Now we have a little bit more information, and we can see that it has a line segment here, right? Because we have two endpoints, just like we just talked about. And could it be a ray? Does seem to have two endpoints. A ray would have to have an arrow at one end, right? Could it be a quadrilateral? Possibly. Who knows how many sides we have hidden underneath there, right? Okay, let's take off this one. Ooh, getting more information now. Could it be a square? Not a square because this side and this side are different lengths, right? Square has all lengths the same. Could it be a rectangle? Possibly a rectangle, depending on what's going on underneath here, because a rectangle would need to have 4 right angles. What else could it be? Maybe a parallelogram, a trapezoid, a pentagon. And I have a special thing. Let me see if I can make it pop up here. There we go. It is a quadrilateral hierarchy that you might remember from Module 5. And I'm going to connect this to this to this YouTube video so that teachers and students can have it and help you study what is a trapezoid, what is a kite, what is a parallelogram, what is a rhombus, what is a rectangle, and what is a square, and how are they related, right? A hierarchy shows you the group of all quadrilaterals is broken into trapezoids and kites, and go on from there. Okay, so look for that in the description just for you. Okay, let's go back. Sorry. Let me go back to, there we go. All right, and like I said before, we're going to solve this mystery at the end of Lesson 12. We're going to draw line segments, angles, and quadrilaterals on the coordinate plane, and we're going to use the coordinate plane to classify quadrilaterals in this lesson. But while we're still looking at this, could we identify the ordered pairs if we called this W, and if we called this X and we called this Y? Can we identify the ordered pairs? A little bit of a review on ordered pairs. Remember, going across and up. So our W is at 8, 17. So 8 is our X and 17 is our Y, across 8 and up 17. Our X, point X, would be also on 8 and 5, so 8, 5, and our Y is at 15 and 5, so 15 across and 5 up. And we don't know what our secret missing point is yet. Is WX horizontal or vertical? Good review. Horizontal or vertical? I hope you're saying that it is vertical because it's going up and down, right? Vert, right? Horizontal is across like the horizon. What is the same and what is different about the coordinates of the endpoints of WX? What is the same? The 8s are both the same because it is on the 8, right? But different because we have a Y of 5 and a Y of 17. Very good. What is the length of WX? What is the length of WX? Well, if it ends at 17 and it starts at 5, 17 minus 5 is 12, so our length would be 12. We could count, but we can also subtract, right? How about XY? Is it horizontal or vertical? XY is horizontal. Good job, right? It is going across just like the horizon line when you're watching the sun set beyond the horizon. And what is the same or different about the endpoints of X and Y? You're right, the Y is both 5, but the X's are different because this is a horizontal line, so it is going along the 5, right? Okay, very good. And what is the length of XY? 15 minus 8, or count up from 8 to 15. This time let's count up. 8, 9, 10, 11, 12, 13, 14, 15. That makes it 7. The length of line XY is 7. Okay, excellent job. And I'll see you in video 2. We are going to be on number 1 in your Learn book. So head on over there and I'll see you there. Thanks so much. Aloha.